Hello, welcome to another video where we're looking at Odin's, developing Odin's, which is an interpreter for the Z machine running in Odin. Um, so, where have I gotten up to? I've done a bit off camera, um, but if we run this now, we can see I've turned off the stack trace, um, showing which instructions are getting called because we're kind of at a stage where it it's like accepting input. It was ah, kind of what my thing does, and now we need to. So basically, it's on the cool. Uh, I think it might actually be good if we do this and wait. Um, cool. Sorry about that. Just took a bit longer. It probably is good to have that for now, so we can see. One of these was from this print, but we're up to the opcode read, and we've done a fair chunk, so it does quite a lot leading up to this. So the read is probably the more interesting one, which is why I thought I'll do this in a video. It's kind of got multiple parts, and for different versions, it does different things. The idea for this is you read in a line, basically until the end of until a new line is found, and you want to kind of put it in the right format. Oh, and also version 1 to 3 status line is automatically redisplayed. I've got capability for that, but I haven't actually written anything for that. I basically just got a fixed man code, I guess I should say. Um, but yeah, so all the characters are written, but then they're yeah, this kind of phrase was a bit weird. Any terminating character, because yeah, I guess it kind of means a word separator. I guess I'll explain more because there's a bit to go with this, bit to kind of consume for this opcode. But yeah, anyway, the gist is that they all kind of get these two arguments at least, and some of them get a time and a routine. We're not looking at the time and the routine because we're just doing version 3, which is before 4. So we're just looking at kind of this paragraph here, plus maybe some more, basically saying the first byte of the text buffer should be the number of letters that could be typed. So that is also, I should potentially check that. That is done just up here. Yeah, do that check. Done equals length. So, and that length is there. This code does it. I just wanted to make sure that I didn't go over accidentally. Weird noises. Could be that. Open up help. So, basically, this is saying read this in, but then the text that you type in should be lowercase, so we make that lowercase. After we get it, we basically add 32, knowing kind of what ASCII is. It, the uppercase and the lowercase are separated by 32 characters, so you can kind of just add 32 to the number. You could do something tricky like add big A minus little a, but then you kind of need to know one's bigger than the other. It's easier just to put weird magic numbers. So then we kind of store all the things in there, and we also include a yeah, we do this. No, that's writing that. I'm just wondering because you're meant to put 0 bytes at the end of where you've read up to, which I guess this would kind of do it. It would write that, and yeah, the code I wrote does make sense. So then, yeah, this is like a really wordy kind of thing. Um, and version 5 and later, it kind of does it +1 because there's also, uh, which I think, did we do that? Yeah, we did. So you there's a few different things to version 5 and above, but I think I've got them handled in a sense that I just throw unimplemented if a specific case comes up, which I think is only 2 games from what I understand. Oh, in fact, it just says it there. 3 games. Anyhow, this is all about the time stuff, so that's like just ignored. This stuff just kind of happens for free in the shell. Um, except like, oh no, yeah, that's in a different place. So here it's like now lexical analysis is performed. So I haven't done that. I've just got some comments on how it's meant to go. And there's like a format that this pass buffer will have. Um, and yeah, it's kind of like you divide it into words and then it kind of links to this document, which is dictionary and lexical analysis. And this talks about breaking up into words, and word separators is kind of described up in the header. So yeah, I've kind of said break up into words. We need to read the header table, then get word separators, and it's got a rule about space if it not there. If it is a space, then it's included, but if it's any of the others, then do include it. And then we have to encode it as a Z string and then search for it in the dictionary. And then based on that search, we write the table. Is just, I love this. And it's like, for the format, you have to see this. So then you have to kind of jump back here. And now that you've understood what this is kind of meaning, then you can reason with the rest. And yeah, so then the string stuff. So it had a couple of rules, I think. And dictionary form. Yeah, so I think this just kind of says it here. So it should be all lowercase, which it already has. And abbreviations can't be used. So would have to change a thing in the work out which character, and also have things for input. I don't know, gotta do some things. The paid character has to be 5, and it's going to be like 6 or 9 words. Um, Actually, no, 6 or 9 characters, and it's 3 characters per word, so like 2 words or 3 words. And it gives it talks about like a random thing that may happen, and then the example is like nothing to do with that. These talks are kind of fun to read. And in version 1 and 2, we do something a bit different. And yeah, this I was just looking up to see how the status line worked, because there's a status line that we're meant to redraw. Right, so I think what I have done here. Oh yeah, I also didn't mention that in here the entries in it are all sorted. So everything must be in numerical order of the text. So if we get the Z string as just a series of bytes, which kind of makes sense, because you could probably then pass those same bytes back to a different function. And because they're sorted, you can do like a binary search on it. So you divide and conquer, split in the middle, search one half, search the other half. And based on which half it is, then you split that one in half. And it goes a bit better than bubble sort, which I guess don't need bubble sort. But yeah, it goes quicker. And then after we do all that, we need to write the past table entry. So I guess in this analyze, we should kind of get to it and see what we get. Not that one. Sometimes I don't know with my keyboard. I think it's more a problem with the person operating. So, break up into words. So, we need to get that header table. We've already got the header. And I forget. What I might do is bring this to there. It does mean I've lost that, but I can. Um, and no, I'll just do it. Come on. Man struggles with keyboard. Header. Just want to see what things we had. So we need to get the. Oh, really, this would be better on the other side, but that's all right. So we want to get the dictionary from the header. Um, Header. And I guess that is all that's required of that. So now it would be useful to have this again. So we want to have the header, this first table. So what do we have? I don't know what just happened there. I think I didn't go into insert mode. Right, so this will be dictionary equals that. We need that in this language. So in is going to be machine read byte. Yep. And we'll give it the machine and we'll pass in the dictionary, and that's all that function needs. So here we have in byte. So separators, is that right? Hey, that's not what I wanted. I thought that was I don't know if that's an E or an A. That looks more right. Right. Anyway, naming things. So this is going to be, how do we do this? Make of U8 and make this in. That how you do it. We can probably see that. That's all right. Off by one there. Right. And I think I want to go into execution and dump. Do something like that. And do something like this and execution Odin and 1 hour 53. And I guess we're an execute. Come on. We'll just call this an info. No op trace pointers, I guess. Just so if I run it without it, no, that won't do it at all. Anyhow, right, so it gets to the bottom here. So back on with this. So we've got the separators. We haven't actually read them yet though. So I guess we make a and do something like that. And here we would want to machine read by machine. This is going to be dictionary plus I plus 1 because we've read a thing, and go here and we want to write separators, something like that. It's kind of long. It's only 70 characters. The font is up quite high. Format dot require sets and we can just pass in separators, and I'll let the default thing do its thing. Well, I'll make this a U32 then, I guess. But then this will you need to cast a lot. In this Odin. Right. So here we can see the separators are that. I wonder if can get that in a slightly better format. Yeah, so what do we have? A comma, a full stop, and a quote. So what's this length do? Right. So it's like not fixed, but no, it doesn't say it's cut off there, but it said it was cut off. Somewhere it did. Yeah, so that kind of says, oh, I guess must be. So I guess what that is saying that you can have more than that. I don't know. It kind of seems like it has to be 6 or 9. Um, but then this kind of says that. Oh, I see. Yeah, I see. I see. That's something I should probably check. Just wondering, we have to have codes that are only input output, which is just standard ASCII and like the extra characters. Yeah, cool. Um, but before using them, probably should make sure that it's defined for both. So, what's this data? Oh, ignores the bytes of data. Cool. That is pretty weird. Right. Anyhow, that we just need to know when we get to the binary um binary search. So, splitting the string that we have. So we have our separators. Like, I kind of want to print out all the things we have in the dictionary just to make sure we're on the right track. But um, yeah, I'll leave that for later. Splitting words. So I guess find out what we can get in uh, strings. This will let us see the side. And what do we want to do? Split something. Let's just have a search for split. Um, this looks kind of good. Yeah, that just looks perfect. Where'd you go? Partition. So I guess we want to get the word. And so the word we've written into memory. I wonder whether this should also. Oh, um, it is a C string, so well, it's kind of stored in as a C string. I think I'll need this one and C string. Can I get a C string from a slice? Um, well, I guess I'll just see if I can kind of um clone from, wasn't it? And the C string that we're going to pass it is just going to be machine dot memory. And so I guess here it depends if it's version 5 or not. Um, do something like this. Um, I don't even know if it'll work. So we have a text uh, plus set. Right, it doesn't like that. Or is it? Nah, we just don't include this. Go back here, add that back in. Right, that doesn't like it. Yeah, so it doesn't. Oh no, we needed to go like the length of it. I guess doing that. But I don't want to get all of it. I wonder if we can. Well, actually, just C string that whole thing. Um, I thought a C string is fine. Gosh, how do I get a C string? Um, How does this one work? Oh, see, no, that's not what I need. Um, um, what about um, I it should just work. Um, that's quite annoying. Like I've got it stored in memory with a 0 byte, but I yeah, I guess. So when we read it, we know the length. It's done. Done. Yeah, we can just. How come it, that was just what I copied there? Cool. Uh, and I think just have that maybe. What was that offset? Um, that one. Right. Uh, something like that, except this. I want to go like that. Um, Right, what doesn't it like here? I never added that. A word is a string. Right, so here's the word. So I think after all that, I want to just return something like that. Don't bother that. And yeah, that makes sense. And then from execution, I think I've got a redoc code, which because it's slightly longer than the others. So I guess this will get us our uh, input. Input. Um, did we say we're going to return a string? Thank you. And we shall take a string. Input. That kind of means we don't need to have that. And it kind of means that we don't need that there. Um, cool. Does it still work? Do this. Right. It's input. Right. So haven't really got much further than we had. I guess we've read the separator, and so now would like to split um, the input based on strings. So there was that strings package partition, I think it was partition. Yeah, partition. This isn't quite what I want because there's three separators and there could be up to 255, I guess. And should probably not send the control characters when I go through actually. Yeah, because it says somewhere that it I'm not sure it says it here clearly. Just lowercase. It's kind of weird because there's like so many different places on the docs that you need to read this. Sorry, I'm just like kind of reading up. That's all that. Um, yeah, I think it's no. Want to make sure that it's yeah, so word separators has to be SCSI for input and output. That was the line I was looking for. Because currently I'm sending something that isn't SCSI, I guess, which I guess would make the encoder kind of give up the ghost. So I wonder if I wonder if that needs fixing. But yeah, the partition, I was also thinking because either one of these three characters could break it up. This partition only takes one separator. What I really need is um, like something to split on any one of them. Um, that's kind of annoying because before I had to kind of do it myself, getting things to a lowercase. This thing here, there didn't really seem to be anything in the standard library, and I think it's the case here that there's nothing that is going to split based on a series of things. And you would think that I could just loop over the separators and do a split on that, but that's kind of doing needless work. Instead, what I really need to do is go through byte by byte um, and see whether any of those bytes are in the separators list or not. And if it's a space, then kind of ignore it, but do the thing. Split multi, perfect. This is what I want. This is perfect. Though it doesn't remember what it was. Because, yeah, this is kind of alright, but it doesn't give you what the separator was back. Hmm. Are there any other function multi? This could work. Um, right. So we index multi. So just trying to, yeah, just trying to think of. I wonder if I can actually go. Something like this. But echo that. Something like that. Um, nah, it doesn't like that. Right, that kind of works. Uh, that way I don't have to type. Right, so anyhow, when we're here, we can use what it was, strings dot index multi, and this was, I might just call them strings, and here we can we make a string from a single byte? Can I do something like this? I cannot. Oh, it's like figure out one thing, then I could clone from pointer. Though I haven't really yeah. Yeah, it's like an array of this one's no good. I think I just need to do it manually. I don't know. Well, actually, no. Now I can I like reassign you to like strings? Will you let me do something like that? Yes, I did. Um, you cannot redeclare it. Because what I could do is yes, clone from pointer. Well, clone from bytes as well. So string stock clone, and we want to pass it separators. But I think I do want this so I can pass the len. Something like this. Um, I think might do the trick. Wonder if there's like kind of functional language style stuff. I think there wasn't really, because I kind of want to map this separators. Oh, in fact, did you let me work? Um, you not overrided. Oh, can we? Yes, that is kind of what I want. This and what else do we have? Just that. String from pointer. because we don't really need to allocate. Yeah, this is how we're doing it. And this is also I can just do the index multi. I do wonder if maybe just comment that out. Right. So it does have like each byte. Though I think it's like as a rune, but can we cast it as a U8? Um, this might be going somewhere. Yeah, that's the better. So, can I do something like this? Well, actually, can I do something like that? And right, it didn't like that. Cool. So from the input, I think we're getting each character of that, and I think if uh, you ate the in separators do format. Well, actually, no, I'll start a thing because we'll need to do something. Um, Something like that. Um, right, we can't do that. From a slice, can we? Uh, any of? I think that's what I want. Contains looks maybe better. Right, so slice dot contains. Gosh, could have include a few different things. And does it contain U8 of the and cool. And now it's only picking up the that that and that. Perfect. So I guess at this point, I might just go here. We can get the word of yeah, we can get the word as just like a substring. Um, get rid of that endless loop. Well, it's not endless. Have something like this. Index plus equal 1 when we get a separator. And yeah, so that's just going to be. We do actually need the. Yeah, I want this to be called offset, and here we need to have an index. Do that. Index is less than length of input, and index is equal 1. So B, we'll call it C. And this is going to be input at index. So if it is separated, then we want to treat it as a word so far. Yeah. And then test the separator as well. And we don't need that. But if C equals space, then this should test word so far, but not the separator. Right, so what is the word so far? Word so far is we also need to set offset equal index plus 1, I would say. Wrong hand. And I guess index should also go up by 1. Same in that case. But the difference is we only rings dot substr. I assume that's a thing. And we can go from. Actually, no, we can just do something like index offset, and we're going to the index. Something like that. And we also need to do something there. And right, so Is char a thing? It didn't. I guess like I just want to do that, but have you print it as a character. Right, so now it's splitting into hide and the comma, then so this if it's a space, yeah, so I guess we need to if it is a space, we definitely just want it's got a weird extra space just after separators. That's not right. Um, right, that didn't quite work. So I guess if word is empty, if when word greater there, do that. Otherwise, we should have that. Um, I might just call that separ so it's a bit clearer. Feel free to say quote mark. It loses the H there, and I wonder. Well, it's probably just losing the space for all those. Um, yeah, I think that is what I wanted. Um, Something like that. Um, so I guess this is kind of a good point to stop for the day. So aiming to get this read done at some point. We've got it into the I don't know, like up to that point, but now we need to kind of look it up in a dictionary, which that requires encoding the Z machine in dictionary form, and that's still to done. Probably another episode worth, but yeah. If you made it this far, thanks for watching, and I'll see you another time.